a quarter-mile wide artery of American commerce carrying 60% of the nation's grain exports, has become a ghost of itself. Not blocked, not frozen, but starved. In the autumn of 2022, sections of the Mississippi River simply began to vanish from beneath the thousands of vessels that depend on it. More than 2,000 barges, a flotilla of stalled industry carrying the equivalent of nearly 2 million semi-trucks, were held motionless in massive maritime traffic jams. The river, the Mississippi, or Great River of the Ojibwe, was running out of water. This wasn't a sudden flood or a chemical spill. It was a slow, creeping subtraction. The water level at Memphis, Tennessee, at river mile 734.5, would eventually plummet to negative 10.8, 1 feet, a depth that approached the historic low set in 1988. At key choke points like Stack Island, Mississippi, the channel became so narrow and so shallow that the U.S. Coast Guard was forced to shut down all commercial navigation. A steel conveyor belt 20,000 tons at a time had come to a grinding halt. The sheer scale is difficult to process. I am curious what you think about this, actually. And here's the detail that tells the true story. Exposed sandbars, some stretching for miles, emerged from the receding water like newly discovered islands. Near Baton Rouge, a local resident named Patrick Ford, walking along the exposed riverbank, discovered the skeletal remains of a 19th century shipwreck, its wooden hull revealed to the air for the first time in over a century. The river was not just shrinking, it was giving up its secrets. But the most alarming part of this story is not what the river revealed. It is the invisible crisis it triggered, an emergency response of gargantuan scale, and the far more sinister threat that was silently creeping up from the sea. To understand what is happening to the Mississippi, you have to understand its immense scale and its fundamental physics. The river is not just a line on a map. It is the primary drain for a basin covering 1.15 million square miles, approximately 40% of the continental United States. Rain that falls in 33 different states, from the Rockies to the Appalachians, eventually finds its way into this single channel. It is a system of almost unimaginable complexity. Harley means the state geologist of Florida used the analogy of a checking account for a disappearing lake. The Mississippi is that concept magnified a million times over. When deposits of rainfall across the Midwest fall below the constant withdrawal of evaporation and downstream flow, the balance goes negative. The account drains. In the summer of 2022, those deposits effectively stopped. A persistent La Niña weather pattern, combined with record-high temperatures, baked the soil of America's heartland. The tributaries that feed the Great River, the Missouri, the Arkansas, the Illinois, slowed to a trickle. The result on the main stem was immediate and catastrophic. The river began to drop, and as it did, it began to shoal. Shoaling is the process by which sediment, the sand and silt constantly carried by the river's current, begins to fall out of suspension and settle on the riverbed. A healthy, fast-moving river scours its own channel clean. A slow, anemic river builds its own obstructions. The congressionally mandated navigation channel, a 9-foot-deep, 300-foot-wide highway for commerce, began to fill in. For the towboat captains pushing their cargo. This is an existential threat. A standard jumbo river barge carries roughly 1,500 tons of cargo. For every single foot of draft, the depth of the barge beneath the waterline, that is lost to a shallow channel, that barge must shed approximately 204 tons of material. That is nearly 8,000 bushels of corn that cannot be loaded. When the channel depth drops from a reliable 14 feet to a perilous 9, or even 8, the entire economic model of river transport collapses. A 15-barge tow, a standard configuration, normally moves a volume of goods equivalent to 870 semi-trucks. With draft restrictions, that efficiency plummets. Costs skyrocket. And the cargo has to go somewhere. But the rail lines and highways were never built to absorb the cargo of an entire river system. The result was not just a problem. It was a $20 billion supply chain crisis, a figure estimated by AccuWeather for the 2022 to 2023 period. This is the part the headlines do not capture. As the river withered, a silent armada was mobilized, the U.S. Army Corps of Engineers. The agency tasked since 1879 with maintaining the river's navigability, deployed its fleet of dredging vessels into a 24-hour, 7-day-a-week battle against simple geology. This was not routine maintenance. This was an emergency. Lou Del Orco, the chief of the operations division for the USACE St. Louis district, described the effort in stark terms. He said they were essentially performing surgery on the river while it was still operating. trying to keep the nation's economic lifeblood flowing. Vessels with names that sound like relics of another era became the front line of this modern crisis. The Dredge Potter, a dustpan dredge built in 1932, was dispatched to the most critical choke points. This 277-foot vessel, one of the oldest working machines in the federal fleet, uses a massive 32-foot wide suction head to vacuum up sediment from the channel floor. In optimal conditions, it can move up to 8,000 cubic yards of sand and silt per hour, pumping it through a floating pipeline to be deposited outside the navigation channel. The Potter, along with its sister dredges like the Goats, the Hurley, and the Jadwin, worked under floodlights through the night, their crews fighting a relentless accumulation of sediment that could undo their work in a matter of days. Tom Heinold, chief of operations for the Rock Island District, further upstream, highlighted the sheer scale of the task. The Corps normally dredges between 200 and 300 million cubic yards of material from the river system annually. During the 2022-2023 crisis, that volume surged by 40 to 50%. It's a volume of earth that is difficult to comprehend. A constant grinding war against a river that was trying to build land where ships were supposed to float. These crews cleared a path for commerce one pipeline of slurry at a time, often in the most remote and challenging stretches of the river. The work they do, so often unseen by the public, is quite literally what keeps the country's agricultural sector from seizing up. If you find these sorts of deep dives into the hidden machinery of our world valuable, a subscription to the channel is what keeps them coming. But zoom out from the dredging operations on the riverbed, and a far more insidious threat becomes visible. This is the danger that has nothing to do with soybeans or corn, and everything to do with the survival of over 1 million people. The bottom of the Mississippi River, from the port of New Orleans all the way upstream to Natchez, Mississippi, at River Mile 363, sits below the level of the sea. It is a geographic anomaly that under normal conditions is kept in check by the immense downward pressure of trillions of gallons of fresh water flowing toward the Gulf of Mexico. This powerful current acts as a hydraulic barrier, holding the ocean at bay. When that flow diminishes, as it did so dramatically in 2022, and again in 2023, the physics of the situation reverses. Denser, heavier saltwater from the Gulf of Mexico begins to push its way upstream, not on the surface, but along the very bottom of the river channel. It moves as a distinct layer, an invisible wedge of salinity advancing northward against the weakened current. For the communities of southern Louisiana, this saltwater wedge is a slow-motion catastrophe. The drinking water intakes for the greater New Orleans area and for Plaquemines Parish downstream are positioned to draw water from the bottom of the river. As the wedge advances, those intakes begin to pull in water with increasing levels of salt, rendering it undrinkable and at high enough concentrations corrosive to the pipes and industrial equipment that rely on it. This triggered a second, even more complex, emergency response from the Army Corps of Engineers. Under the direction of Colonel Brandon Bowman, the commander of the New Orleans District, crews were tasked with an extraordinary feat of engineering to build a temporary dam underwater near Myrtle Grove, Louisiana, at River Mile 64. Barges and cranes worked around the clock to construct what is known as an underwater sill. They did this by dredging approximately 300,000 cubic yards of sediment from the river itself and piling it into a massive ridge on the river floor, an artificial mountain 15 to 20 feet high stretching across the channel. This sill acts as a barrier, physically blocking the dense saltwater wedge from continuing its advance upriver, while allowing the fresher, lighter river water to flow over the top. The first sill was built in the fall of 2022. As drought conditions persisted into a second year, the Corps was forced to build another, one in October of 2023. It is a desperate, temporary measure. The sills must eventually be notched and then completely removed once river flows recover to allow for the passage of deep draft ocean-going vessels that use the lower river. It is a monumental effort, a project of building and deconstructing underwater mountains, all to protect the water supply for over 1 million American citizens from an invasion by the Atlantic Ocean, 100 miles inland. This dual crisis, the commercial stoppage upstream and the saltwater intrusion downstream, carries a staggering price tag. Mike Steenhoek, the executive director of the Soy Transportation Coalition, has called the Mississippi River the circulatory system of American agriculture. When it constricts, he says, the entire economy feels the effects. The numbers bear this out. The USDA's Agricultural Marketing Service tracks transportation costs. In the depths of the 2022 crisis, The cost to ship a ton of grain by barge from St. Louis southward skyrocketed by over 150%. A transportation system prized for its low cost. Inland waterways saved the U.S. economy an estimated $7 to $9 billion annually compared to rail or truck, suddenly became prohibitively expensive. This is not a theoretical economic model. Each day the river is closed has a cascading effect. Waterways Council, Inc., an advocacy group, estimates that a single day of closure on the Mississippi can cost the U.S. economy close to $2 billion in delayed cargo and logistical chaos. When you trace the supply chain backward, a single stalled barge tow at Memphis can translate into higher food prices in Europe or Asia a month later. It's a connection most of us never see. A global economic dependency on the water level at a single gauge in Tennessee. Might be worth sharing this with a friend who'd find that interesting. Anyway, this is the domino effect in real time. Farmers in Iowa and Illinois, unable to move their harvest downriver, face plummeting prices for their crops as storage silos fill to capacity. Food processors and exporters dependent on the river face contract defaults. The American Waterways Operators, the trade association for the barge industry, saw its members forced to tie up billions of dollars of equipment waiting for water that was weeks or months away. The crisis of 2022 and 2023 has its precedents. The river has experienced severe droughts before, most notably in 1988. But what experts like Louisiana state climatologist Colin Laborde are now pointing out is a change in frequency and severity. The conditions that led to the crisis are becoming less anomalous and more like a recurring feature of our changing climate. Major General Diana M. Holland, who commanded the Corps' Mississippi Valley Division during the initial 2022 crisis, oversaw the first wave of this unprecedented response. Her successor, Brigadier General Daniel H. Mitchell, has been left to manage the continued fallout and plan for a future where these events are no longer historic, but cyclical. The problem is compounded by the age of the infrastructure tasked with fighting the problem. The Dredge Potter, the heroic vessel from 1932, is a potent symbol. It is a testament to incredible engineering that it still functions, but it also represents a system that is old. The nation is relying on 90-year-old equipment to combat a 21st century climate problem. While the 2021 Infrastructure Investment and Jobs Act has allocated more funding for inland waterways, the scale of the challenge is immense. You cannot simply build a new river. And then there is the ecological toll, a story written in the newly exposed mudflats. The Mississippi Flyway is a superhighway for migratory birds. The shallow backwaters and sandbars of the river provide critical habitat. Extreme low water events dramatically alter that landscape. Fish populations, like the bluegill largemouth bass and gar mentioned in the Florida Lake story, become concentrated in the few remaining deep pools, making them vulnerable to disease and predators. The entire food web of the river is compressed and stressed. The system is resilient, but the National Weather Service hydrologists and the USACE biologists who monitor it are witnessing a system pushed far beyond its normal bounds. By the spring of 2024, precipitation returned to the upper Mississippi Basin. The river began to rise, the saltwater sill was notched, then removed. Barge traffic resumed its normal drafts. The immediate crisis receded. But something fundamental had shifted in the perception of the river's reliability. The $20 billion bill from the last drought serves as a stark reminder of the system's fragility. The core misconception is that dredging is a permanent fix. It is not. It is a temporary treatment for a chronic condition. The river carries 500 million tons of sediment toward the Gulf every year. The moment a dredge moves on, the channel behind it begins the slow process of filling in again. The surveillance of the river is constant. The USACE operates over 100 river gauges, reporting real-time data on water levels and flow rates. The National Weather Service's Lower Mississippi River Forecast Center in Slidell, Louisiana, runs constant hydrological models, attempting to predict the river's behavior weeks in advance. But they are modeling a system whose historical patterns are becoming less and less reliable as a guide to the future. The entire event forces a confrontation with a few difficult questions. The United States has engineered this river for 2 centuries, building levees to contain its floods and dredging channels to secure its commerce. We treat it like a machine, a predictable utility. But the drought revealed the raw, untamable power of the natural system that underpins it all. When the rain doesn't fall 1,000 miles away, the machine breaks down. And the story isn't over. It's just paused. The memory of those 2,000 stranded barges, of an underwater mountain built to hold back the ocean, and of a 19th century ghost ship emerging from the mud, now hangs over the river. It's a warning. The river gave a demonstration of what it looks like when its flow diminishes, and the cost was measured in the tens of billions. So 3 questions linger over the Mississippi Basin tonight, long after the water levels returned. First, if these severe droughts are no longer once-a-century events, but are becoming a feature of our climate, how much prolonged pressure can this aging infrastructure of dredges and locks actually withstand? Second, what is the true cost of making America's central artery resilient? A cost that must be